Okay, can you please tell me about yourself?
Yeah, sure. My name is Ravi, and I have around 3.4 years of experience. So, mostly I work at the backend development. Currently, I'm working with TCS, where I am the part of the development team. From there is a product called Credit 360 Banking. So, my current tech stack includes Java, Spring Boot, Kafka for event-driven architecture and microservices. So I also have been actively working with Oracle DB and PLSQL. And apart from that, I have also worked with the optimization of database queries. Apart from that, I also participate in code reviews, performance optimization, and I also collaborate closely with the cross-functional teams, including the front-end developers, QA, and DevOps. So yeah, I'm working as a backend developer predominantly. So yeah,
Okay, fine. Okay, what is the latest version of Java you are working on?
currently I'm working on Java 17. So earlier I was working on Java 1.8, and now we are working on 17.
Okay. So what are the features of Java 17, you know?
Yeah, it has sealed classes, then pattern
Okay,
matching.
have you worked on seed classes?
Yeah, I have a little bit of the main purpose of this sealed classes are to restrict which class can extend or implement a given class or interface. So in order to use it, so when declaring a sealed classes or interfaces, we can use sealed modifier followed by the permits clause, which lists the specific classes that are allowed to extend it. For example, let's say we have a vehicle class and we want that to permit for the let's say car and truck class. So we can simply say like public sealed class vehicle and then permits car or truck. So we can do like that way. So a vehicle will be the sealed class and car truck are only allowed to extend it. And apart from these two, this vehicle and sorry, apart from these two car and truck classes, if any other class tries to extend vehicle, so it will throw the compilation error. So yeah.
Okay, so what are the challenges you faced while migrating from Java 8 to 17?
Yeah, we faced many issues. So one was that removal of deprecated APIs. So Java X, some of the uh, uh, Java X libraries has been removed. So those were there. And then we also had to upgrade our Maven plugins and dependencies to make it compatible with 17. So basically, some older version of frameworks like Spring Boot did not support Java 17. We had to upgrade them also. And then apart from that, some reflective access uh, also that was throwing error and warnings, or it was failing at runtime because of the strict encapsulation in newer JDKs. So we used minus add opens flag as a temporary workaround until the libraries were updated. So yeah, so those are the changes and challenges we faced.
Okay, what is array list and how does it work internally?
Yeah, array list is something in which we don't have to mention the size of the items which need to be added. So internally, array list uses the regular array object to store elements. So when we add elements to the list, so then initially an array, so actually initially the array list will be having the default capacity of 10. So as we keep adding the elements, so it stores them into the array, and once it reaches the threshold, then it automatically resizes the internal array to the bigger size based on some formula, and further it continues to add the elements to it. So yeah, so that's the internal working. And So
Okay, fine. So can you tell me its features or some key points of it?
yeah, so features are like the insertion order is maintained in case of array list, and it allows the duplicate elements and null values, and also it provides the random access to elements using the index. So we can say get of index number, so it will give us the that data. And also it is not thread safe by default, so we need to use a synchronized list if we want to use the thread safe one.
Okay, fine. Okay, so tell me one thing. As you said, the default capacity of the array list will be there. Some number will be there, right? Now, suppose I want to manually set the initial capacity of this array list. So can we do that?
Yeah, we can do that actually. So as soon as we say new array list, and then we have the brackets right in the end. So there we can give the capacity. So let's say we say 100. So it will be setting the initial capacity of that array list to 100. So we can do that way.
Okay, have you used linked list and can you tell me more about that?
Yeah, I have used linked list, and more specifically, I have worked with linked blocking queue in my current project. So which internally we have similar to linked list. So we used to we used it to queue runnable task in the backend processing layer. So one of the main reason for choosing it was that it preserves insertion order, so which was critical for the execution task in the sequence they arrived. The linked structure allowed us to efficiently traverse elements and maintain consistency in processing. So since it is a blocking queue, so it also helped in handling uh, uh, producer consumer scenarios by providing built-in thread safety and blocking behavior when the queue is empty or full. So yeah, so that is how I have used it.
Okay. So can you tell me why did you use linked blocking queue over the queue implementations? Like we also have array blocking queue, right? We also have concurrent linked queue. So why did not you use them and you used linked blocking queue?
Yeah, I chose this one because um, some regions are there like related to performance and blocking behavior and capacity flexibility. Linked blocking queue provides built-in blocking support, so that is ideal for the producer consumer scenarios. So when the queue is empty, consumer threads will automatically block and wait until the time is available. Okay, so similarly, if the queue is full, producer threads will wait until the space becomes available. So this was more relevant to use. So if we are going to use concurrent linked queue, so that is a non-blocking, so we cannot use that. And again, coming to this capacity management, so linked blocking queue that can be constructed with either a fixed capacity or a optional capacity. Okay, so we can give max value like in the case of integer by default. These were the reasons, and also thread safety and synchronization was also another reason. So yeah, so these were the reasons why we used it.
Okay, good. Do you know about heap and stack memory in Java?
Yeah, I am aware of it. So stack memory that is used for the storing method calls and local variables, and heap memory is used for the storing actual objects and class instances at runtime. So like each thread in Java has its own stack, okay, and when a method is invoked, a new stack frame is created for that method. So that is uh, done in the stack memory. Primitive types and references to objects are stored also in the stack. Okay, and then in heap memory, like when we create an object using the new keyword, like new string of anything like hello, the object is allocated in the heap. Okay, and the reference to that object is stored in the stack. Okay, so that is how this heap and stack is related, and that is how the data is saved to the heap and stack memory. So yeah, and also this memory in the heap is managed by garbage collector, so that happens automatically internally in the Java. Yeah.
Okay, fine. Okay, tell me how many methods are there in the object class?
Yeah, so in object class in the Java, so that is the root class. So there are many, so like hash code is there, equals to string is there, and then clone is there, and notify all. So yeah, these are the ones I'm able to recall. Finalize is there. So yeah, these are the ones I'm able to recall.
Okay, so you mentioned equals and hash code, right? So why it is important to override both in a custom class? And also what happens if you override only one of them?
Yeah, in Java, if you override equals method, we should always override hash code as well to maintain the general contract between these two methods. So especially when the objects are used in hash based collections, maybe in hash map, hash set or hash table, especially. So actually this contract says that if two objects are equal according to equals, then they must return the same hash code. Okay, and if two objects have the same hash code, they may or may not be the equals. I mean, but unequal objects should ideally produce the different hashes to avoid collision. Okay, so this is what is the contract. So if we override only equals, so and we have a different hash code, so a hash map or hash set will treat them as a different entries. Okay, so let's say we have a um, let's say we have a hash set, okay, and hash set of employees, okay, and we are saying set dot add of new employee of, let's say it has ID and name. Okay, so new employee of 1 comma let's say Ravi, and again we say uh, uh, just we try to say set dot contains new employee of 1 comma Ravi. So this may return false because the hash code might be different. Okay, so that's one thing. And suppose we override hash code only, so if equals still uses the reference comparison, means a double equal to instead of equals, so and not logical comparison, then the hash code may match but the object won't appear equal. So again this will break the logic. So yeah, so ultimately we should override both of them.
Okay, so what is the difference between interface and an abstract class?
Yeah, both interface and abstract class are used to provide the abstraction in Java. So the main purpose, so interface is used to define a contract that implementing classes must follow. So it represents pure abstraction. So abstract class like is a incomplete class, we can say, so that can contain both abstract methods, maybe means that without body, and concrete methods as well with implementation, that means. Okay, so it represents partial abstraction. So so interface is like the way of uh, achieving 100% abstraction, but abstract class is the partial abstraction.
Okay, so can the interface have constructors?
No, no, no. Interface cannot have constructors, and abstract class can have constructors. So, because we cannot create the object of interface, right? So, yeah.
Okay, can you tell me the real world scenario in your project when you went to choose abstract or interface?
Yeah, so the decision to use abstract class or interface in the real world scenario depends on what kind of relationship the classes share and what functionality needs to be shared or enforced. So, for example, when let's say uh, we have a payment system, okay, and we are building an e-commerce application that supports multiple payments, like let's say we have credit card, Google Pay, UPI, right? So all those are there. So these payment methods may not have the direct relationship, but they share the common behavior, right? So they all support a pay operation, right? So we have the payment method, right? So uh, that is there, okay. So we can define the payment method interface, and under that we will have the pay uh, method, pay operation. Under that we will have, so each payment method can implement this interface. So here we can use the interface, okay. So coming to the abstract classes, so we can use abstract class because they share the common data fields and default behavior methods like a start engine and all. So abstract class allows to have both abstract and concrete methods. So yeah.
Okay. What is the difference between system.out, system.error, and system.in?
Yeah, system.out is a standard output stream, and it is used to print like normal message to console. So whenever we want to print any kind of logs and all, so we use that. System.error is like for the standard error output stream, and it is used to print the error messages or exceptions in the console whenever it happens. And system.in is the standard input stream, so that is used to read the input from the console. So from the, I mean, usually whenever we type anything from the keyboard, so in that case we can use system.in, and for that on that input stream we can wrap use like a scanner or buffer reader, so all that we can use to read the input. So yeah, so this is the difference between these three.
Can system.out and system.error be redirected separately? And if so, why and when you should do that?
Yeah, system.out and system.error can be redirected separately in Java. So this is particularly useful in real world scenarios where we want to separate normal logs from the error log. So especially in the production environment, we can use that. So we can redirect these streams using system.out method and system.error method by passing the new print stream. Okay, so we can do like that. So we can give a print stream out equal to new print stream, and then a new file, whatever the log file we want, we can give that name. Okay. For example, whenever in web application, suppose it is running on the Linux server, then system.out could be logged to the some output.log, okay, and system.error we can log to the error.log. So like this way, if the app is crashing, suppose it crashes or it throws the unexpected exception, so we can quickly check the error.log without going through the all info debugging message. So yeah.
Okay, so you have two overloaded methods, one that accepts an object and another accepts the string. Okay. Now, suppose you pass null as the argument. So, which method will be invoked and why?
Yeah, when we pass null to overloaded method, so Java uses the most specific method available. Okay, so in this case, since string is the subclass of the object and object overloads are applicable, sorry, the string is subclass of object and both overloads are applicable, so the string version will be invoked because it is more specific than object. Okay, so the more specific one will be always loaded. Okay, so this decision is basically made at the compile time by the compiler. So yeah, so the string one will be invoked first.
Okay, so how can you implement multiple inheritance in Java using classes?
Uh, Java actually does not support multiple inheritance with classes. So actually, if we are going to implement that way, so it generates the diamond problem. So it does not support multiple inheritance using classes, but it does support multiple inheritance with interfaces. So using interface, a class can implement multiple interfaces. So suppose we have a interface A, interface B, and both have the same method. And since we don't have the implementation over there, so if suppose any class is implementing both A and B, so anyway we have to override that method, right? So that can be easily done, and that's why multiple interfaces will support the multiple inheritance. Now coming to classes, if suppose two different classes have the same method name with some different kind of implementation. So suppose any class which is inheriting those properties of that parent class. So uh, if the that same method if we are trying to use here, so we don't know. I mean, it is we cannot say that which method will be implemented here, right? So ultimately it will be the ambiguity, and it will show the compilation error. So yeah, so that's why multiple inheritance is not supported using classes, but it does support using interfaces. So yeah.
Okay, okay, fine. So interfaces can also implement default methods, right? So what if interfaces have default methods with the same signature?
Yeah, if both interfaces have the default method with same signature, then the whatever the class is there, which is implementing those interfaces, that has must that should must override and resolve the ambiguity. So for example, let's say we have interface A and interface B, and both have the default void show. Let's say, okay. Now suppose we have a class which is implementing that A and B. So we must have to override here this show method. Okay, and here either we can give the its own implementation, or we can use super. So suppose if you want to use the method which has been defined in A, so we can say a dot super dot show. So that's how we can actually bring up the implemented part of the interface A. So yeah, so that's how we can do it.
Okay, can you explain the whole hierarchy of custom exceptions in Java?
Yeah, so we have throwable, which is the top level class or parent class of all the exceptions. So throwable is on the top, and then under that we have a, exception and error. So error is something like which is irrecoverable situation. So once any error happens, so it cannot be recovered. So examples like we have virtual machine error related, like out of memory error and a stack overflow error and all. So all those comes under the error. And then coming to exceptions, so we have a checked and unchecked exception. So checked exception is like also called compile time exception, and unchecked is runtime exception. So checked exception happens at compile time. So it is going to be checked at compile time. So examples like input output exception is there, then SQL exception is there, file not found exception is there. So all these comes under the checked exception. And unchecked exception, as I said, it is the runtime exception. So let's say any number divided by 0, right? So arithmetic exception and array out of bound exception, null pointer exception, right? So all these comes under the runtime or unchecked exception. So yeah, so this is what is the whole hierarchy of the custom exception.
And in case of Spring Boot, how do you handle that?
Yeah, in case of Spring Boot, we have add controller advice. So like REST controller advice is there. So in that basically we write the global exception handling, and on top of the that global exception, on top of that class we can write at the rate of controller advice, and then there we can under that, under the method level, we can write exception handler, and there, like whatever the response we want to return, so that as a response entity we can return there, return and return new response entity and http method, and whatever the error is there, so that we can return. So that's how we can do in case of Spring Boot.
Can you tell me how does Spring Boot works internally?
Yeah, Spring Boot, um, so in the beginning we have the, suppose we are using Maven, and also uh, in the beginning we have the starter dependencies, like we have Spring Boot starter web, so that will uh, uh, automatically, and it will start quickly without needing the configure each dependency manually. So most of the dependency it will automatically load, and then we have Spring Boot auto configuration. So the it uses enable auto configuration annotation, and Spring Boot application is there. So underlying to that we have again three more another annotations. So like at the rate of configuration, at the rate of enable auto configuration, and at the rate of component scan. So for beans we have at the auto configuration, and for enable auto configuration we have enable auto configuration, and for to scan the packages and from wherever the beans need to be created, so from the packages, so all those packages will be scanned using at the rate of component scan. Okay. Then we have various configurations in the YAML file. So Spring Boot automatically loads configuration from the config files like YAML files, and it create beans, and it anticipates whenever we may need. So it enable auto configuration and component scanning. And then we have Spring Boot application.run. So from where the actual Spring Boot application starts running, and all the application context is started creating. And then we also have the embedded server, like Tomcat and all can be already embedded, so we don't have to separately add the servers. So yeah, so the combination of all these together, that is how the Spring Boot works internally.
Okay, can you tell me what is Spring Boot Actuator?
Yeah, Spring Boot Actuator is a built-in module in Spring Boot that provides production-ready features for monitoring and managing the application. So it provides various endpoints by default. So like we have health, metrics, environment, and all that. So all those activities we can do, and we are using Spring Boot Actuator along with Resilience 4J to track the circuit breaker metrics or failure rates and all. So it's basically useful in microservices for observability and integrating with monitoring tools like Prometheus and Grafana. So yeah, so that's how we use Actuator.
Okay. And what is Spring Initializer?
Yeah, Spring Initializer is a web-based tool. So like start.spring.io. So that helps quickly bootstrap a Spring Boot project. So suppose any Spring Boot project we want to develop, so we go to that URL first, and there we can choose the project type and Spring Boot version and all dependencies like JPA, security, and all we can add there. And then we can also define the group artifact and package structure, all those things we can do. Ultimately, whenever we download it, that final project from that website, so it gives us the pre-configured pom.xml, or if it is Gradle, then build.gradle file, and all the structures will be there. So we are good to start from there in our project. So yeah.
Okay, so how to enable debug log in Spring Boot?
Yeah, to enable debug log in Spring Boot, we can configure it in application.yml or application.properties file. So, like in the hierarchy, we can give logging level, and then the package type, your package we can give as debug, and similarly in properties file we can give, and also we can run the application with debug mode enabled by a command line also, suppose if we are doing it through command line. So yeah, so we can do it. So for troubleshooting during the development, it is very much helpful. Yeah.
Okay, do you know dev tools in Spring Boot?
Yeah, DevTools in Spring Boot, it enables automatic restarts on file changes and live reload for front-end assets and all. So it basically it is enhanced debugging support. So we can do using that.
What is Spring Boot profiles? Do you know?
Yeah, profiles allow us to define the environment specific configuration. So suppose we have multiple environments, right? We have production, we have dev, QA, right? So suppose some functionalities we want to run on different environments, and so basically as per the environment, different functionality we can run. So we can use in the YAML file, like we have Spring profiles and active, we can give their dev or QA whatever we need. So basically this helps in managing different configuration like database URLs, any credentials are there, any logging we want to do based on the different environment. So all those things we can do using this. Yeah.
Okay, do you know Spring Boot test annotation?
Spring Boot test. Uh, it is used for integration testing in Spring Boot. So it loads the full application context. So we can write tests that validate the controller endpoints and that interacts with the real DB. Okay, and that perform full request response cycle. So all that we can do using this annotation. Yeah.
Okay, so in microservices, what design pattern is used to build and communicate between microservices?
Uh, the API gateway pattern usually that is used to manage the communication between the clients and backend microservices. So any request which is coming from the client, so API gateway is the first entry point. So from where all the uh, request goes from there to, and again API gateway further it goes to the service discovery, and at service discovery it tries to find out the corresponding whatever the dynamic URL which has been generated, so that can be found there, and further request goes to there, whatever dynamic IP address is there, so there the request goes. So yeah, so this API gateway is the centralized routing, and all kind of rate limiting, authentication and logging happens here. So yeah.
So have you used a discovery registry like Eureka or something?
Yeah, I haven't directly implemented a discovery registry myself, but I am familiar with the concept and uses of the Eureka server and in microservices. So a discovery server allows services to register themselves dynamically, and other services can discover them without hard-coded URLs. So this enables load balancing and resilient communication. So especially in cloud native deployments. So in Spring Cloud, service registers with Eureka using the enable Eureka's client, and consumers use at the rate of load balanced REST template or fin client to discover them. So yeah.
And do you know the circuit breaker?
Yeah, I have implemented circuit breaker using Resilience 4J in our project. So circuit breaker is a design pattern that prevents the application from continuously trying to call a failing service. So suppose for some reason it is not able to connect with that. So it basically avoids the cascading failures. And with Resilience 4J, uh, we can implement the circuit breaker. We have to give the retries, so to attempt the retries with back of before failing. Okay, so we can give the how many number of retries can be done, and further we have a fallback method. So suppose the retries are finally failed, so at the fallback we can write the fallback method. So whatever in the method, whatever the decision we have taken to do if in case of the failure, then that we return as a part of the request, as a part of response, sorry. Yeah.
Okay, what is service mesh and have you used anyone?
Yeah, service mesh is an infrastructure layer that facilitates service to service communication in microservice architecture. So yeah, so it handles basically routing and security, it tries the circuit breaking and all. So I haven't used anyone directly in production, but I understand its architecture and how it offloads operational concern from service to mesh. So yeah.
Okay, so you do hibernate as well, right?
Yes, yes, I know that.
So what are the core interfaces in Hibernate? Can you name?
Yeah, I haven't used recently on that, but the main interfaces I remember, like session is there, transaction is there, then session factory is there, then query criteria, and also yeah. So these are the ones are there.
Fine. Okay, so in SQL, can you tell me what is the use of union, union all, and intersect?
Yeah, so union basically combines the result of two select queries and removes the duplicate rows. So that's what is the union. And union all combines the results without removing duplicates. So that's the union all. Okay. And then intersect basically that returns only the common rows between the select queries. So it is used whenever we are interested to share the records between two databases or something like that. So yeah, so these are the differences between these.
So how many types of joins you are aware of in SQL?
Yeah, I am aware of inner join, left join, then right join, full join. Yeah.
Okay, can you quickly, in one lines, can you explain all of them?
Yeah, inner join basically that returns only the matching records between two tables. Okay. So the basically it will be a common one between the two tables. And left join is basically it will return all records from the left table. Okay. And the matched record from the right table. Okay, so that's what will be the left join, and right join will be the reverse of it. So basically it will return all the records from the right table and matched record from the left table. And then again full join will be the like combination of left join and right join. So it will return all the records whether where there is a match in one of the table. So it will return either of them. So I mean it will return the combination of both of them. So yeah, so this is the differences there between these two.
What is the difference between GPA and Hibernate?
Yeah, JPA stands for the Java Persistence API. So JPA is a standard specification for object relational mapping, ORM in Java. So Hibernate, so JPA we can say it is like kind of interface, and Hibernate is kind of implementation of that. Okay, so Hibernate is the implementation of that JPA specification. Okay, so JPA is a specification. So when we are using Spring Data JPA, so technically using the Hibernate under the hood. Yeah, so that's the difference between these two.
Okay, what is lazy and what is eager fetching in JPA?
Yeah, lazy fetching is related to data. So in lazy fetching, related data is fetched only when accessed. Okay, and eager fetching is like related data is fetched immediately with the main entity. So that's the difference between these two.